Okay, as people are kind of slowly gathering, I'll just remind everybody what the rest of the schedule looks like for the day. So we have a keynote talk from Peter Bickel. I have learned very quickly as a chair that one of the best things you can do is to delegate. And I have asked one of our cherished alumni, Lisa Lavina, to introduce Peter. So she will do that shortly. After Peter's keynote, we're going to have an alumni panel that's moderated by Ben, and our panel has some seats around here. And then after that is a reception. And during the reception, I hope maybe the AV team can leave the mic on. I want to invite everybody to come and give any reminiscences, remarks, especially our alumni, about their time at Berkeley, and that'll be very unstructured. So you can start thinking about what you want to say now, if you'd like. And without further ado, Lisa, please take it away. Introduce Peter.
All right, so I had about a 1-minute notice on this, but I enjoy introducing Peter, so I'm happy to do that. Peter is one of the original Berkeley legends. He got his PhD from Berkeley in 1963, and he's been on the faculty ever since. So that is a long time. The list of Peter's awards is very, very long, and I won't give you all of them, but I'll mention a few of them. He is a Guggenheim Fellow, a MacArthur Fellow, an NAS member, a COPS Award winner. One of his more unusual titles is Commander of the Order of Orange-Nassau, awarded to him by the Dutch Queen for his contributions, essentially by the ambassador, but the Queen authorizes all of them, and many, many others. I was Peter's student more than 20 years ago, and Peter has been a wonderful mentor to generations and generations of Berkeley students and other young people in the profession. And just one thing that I want to say as a former student about Peter is that Peter has the tendency to assume that you're much, much smarter than you actually are. Every time. And I think that's what got me as far as I am. Peter just believes in you no matter what you do. And then eventually somehow it has a tendency to work out. So today we're lucky to hear from Peter about the department story and the history, for most of which he was here.
Thank you. Oh, I don't need to do this, actually, but I will. I do. Okay, fine. All right. Thank you, Lisa, and as usual, I'm embarrassed by your introductions. But this is a difficult kind of presentation to give because there's no math in it, right? Anyway, I also, before starting, would like to thank two people, particularly Peng Ding, who worked with me on these slides, and my wife Nancy, who made them into real English. So let me proceed. And okay, so first of all, I haven't got it down there, but the question is, why me? Well, Brian has sort of indicated it, because I realize, the oldest member of the department who's around still. So my department age, as he said, I graduated I actually got my degree in 62. I think I already got it wrong. I have 65 there. In any case, it's well into the 60s. But the age of Berkeley statistics is actually much longer than 70. It's 87. It really started, as you'll see, when Neyman came to Berkeley. And so this talk will be an overview of the past, which is, of course, an impossible task, since the past is at least 87 years, not to speak of the previous history of statistics. But it has I'll try and hit some high points and anecdotes. And then at the end, I can't resist pontificating a bit, or at least raising, what I view as a big challenge. Apologies, as you see, I'll dwell largely on the faculty and research and statistics because that's what I did. I will not much talk about the students and staff. I will talk a little bit about probability, and I won't talk about the undergraduate curriculum. Much. I will talk about it a bit. So my themes are the history, the evolution of the department in terms of people, curriculum, and research, and the evolution of the fields, statistics, theory, application, and computing. And since I won't be saying too much about probability, details of probability theory, I think I should point out that it's become central to mathematics in general, and in fact, in all its various meanings, central to thinking in the world. I will also speak about people, but I'll try and only speak about people who are gone or not in the audience. Let me give some references to at least the early part of the talk. Constance Reed has a wonderful book on Neyman. She actually was the sister herself of Julia Robinson, who solved one of Hilbert's problems. But Constance was not a mathematician, but she wrote beautiful biographies of Courant and Hilbert, and then was persuaded by Eric Lehman to write one of Neyman, which is really quite delightful. Eric Lehman, who wrote, Eric Lehman, Jerzy Neyman. That's an obit. And then he wrote a couple of books, Reminiscences of a Statistician, The Company I Kept, and Fisher, Neyman, and the Creation of Classical Statistics. And finally, there's a 2 or 3 page department history by Terry Speed, Jim Pittman, and John Rice. Okay, so as I suggested, I'll talk a little bit about the history first, and there is prehistory even before this. But for example, how did Neyman come to Berkeley? But Neyman did come to Berkeley, and that's sort of the start of the story. And he came in 1938, and he formed the statistical laboratory or group within the math department. Then came World War II with a new appreciation both of statistics and of science in general. I mean, this enormous funding that is now being taken away by President Trump wasn't present until the Second World War. It was after the atomic bomb that suddenly the government realized that really they should pour more money into research, and they did. The founding members of the department in '55 were the following. Neyman was the founder, the super founder, if you want. And then the other names were Ed Barankin, David Blackwell, Evelyn Fix, Joe Hodges, Lucien Lecomte, Eric Lehman, Michel Loewe, Henry Chaffee, and Elizabeth Scott. And actually, for a while, Charles Stein was a member of the Berkeley faculty, as was Pao Lu Shu, who actually went back to China and is actually known as one of the major figures in founding Chinese mathematics. I mean, mathematics in China now. Neyman's people, so I'll describe the people whom he brought. The main sources were Berkeley and Columbia. He tried at Columbia for Abraham Wald, who was the head of the department, for Herbert Robbins, whom I think you've all heard about also. And he got Charles Stein, actually, but Charles was lost during the year of the oath in 49-50, when one had to, this was the loyalty oath demanded by the regents of the University of California. And then he also hired the more senior, but also very distinguished, Henry Chaffee. As you can see, there are a lot of people among these as you can see, as I list really, who are his students, Neyman students, Fix, Hodges, Lecomte, Lehman, Elizabeth Scott, who had got her PhD in astronomy, were all Neyman students. And the way he was able to do this was he convinced the administration that there was no possibility to hire broadly because few universities were doing statistics. And this was correct. He also hired in probability Ed Barankin, who was in mathematics, David Blackwell, eventually from University of Illinois Urbana-Champaign, although that's where he got his PhD. He actually when he was hired, was chair at Howard University of Mathematics. And he also, and Blackwell was a student of Joe Dubs, and Neyman tried his best to hire Dubs too. Michel Loewe from France was a student of famous probabilist Paul Lévy. Neyman had enormous energy, vision, and also judgment, as you can see, in terms of the people whom he hired. He also was not an easy man on the administration because he was always asking for things and usually getting them. But he also worked not only on Berkeley but also on the profession in some ways. And one of the things that he did, which actually brought a lot of international attention to Berkeley, to probability, and to statistics, were the Berkeley Symposia. There were 6 of them, once every 5 years, starting in 1945. This brought leading probability theorists and statisticians from all over the world together. And at that time, probability, believe it or not, was still a relatively unfashionable part of mathematics, at least in the US. In Russia, it was actually major, since Kolmogorov was there. And in France, it was quite major, but not so much in the US. And statistics had only begun as a discipline, separate discipline. He led the group in the math department until 1985, when he left. He and the group exited the math department. He was very briefly, I think, chair, and then when Blackwell was hired and Blackwell became chair. Okay, now I want to talk a little bit about the intellectual climate of the department to begin with. And of course, as you might expect, it was set to some extent by Neyman. So Neyman viewed himself as an applied statistician. In fact, of course, he had his degree in topology from, I believe, the University of Warsaw under Sierpiński, who was a famous Polish topologist. And in fact, he always claimed in this lovely book of Constance Reid's that his really first love was the Lebesgue integral. But in Poland, of course, jobs for mathematicians and statisticians were not that easy to get. And he headed an agricultural research facility before the war. And that's where he, in fact, began to develop statistical ideas. He engaged in it when he came to Berkeley. He was brought to Berkeley by an amusing set of circumstances, which I will not go into unless asked. He was engaged in important applied work during the war. I jumped. During the war and working in astronomy and other subjects with Scott. Now, he was brought to Berkeley and began to build this department. And from the very beginning, he distinguished, at least Constance Reid makes this point strongly, between what he called general applications versus particular ones. And he called the former conceptual, which coincided with probability models and methodology, and preferred these, actually, in his hiring. So the department focused on probability and mathematical statistics, but was always open to new ideas and joint appointments. Initially with electrical engineering, Aram Tamazian, who was an information theorist, and economics, Roy Radner. There are attractive department features that were present from the beginning and that have persisted. The excellence of the department, I think that's reasonably recognized. Welcoming to people with broad interests and to joint appointments. Drawing students and faculty from all over the world. I mean, American students were in the minority when I was a graduate student, and I think maybe they still are to some extent. But the other students came from all over, large contingent from India, from Europe. There's a whole bunch of Norwegians, Canada, and Australia. In fact, Canadians at my time were also the plurality among the faculty, as it turns out. The atmosphere was very friendly, again, from the beginning. There were departmental picnics. There were the Berkeley-Stanford colloquia. The other department was also small. And we really, quite a few friendships were established between the faculty. There were also steady celebrations arranged by Betty Scott and largely Ann Neyman. And there was entertaining at faculty homes. Again, all of these are things that can be done easily when the department is small. Now, let me get to some intellectual threads, which you may have heard of. Here are sort of three foundational figures in probability and statistics in this century. Of course, R.A. Fisher, whose ideas included parametric models, likelihood, sufficiency, randomization, design of experiments. And he worked in the British tradition. I'll make the distinction clear a little bit later. Then Neyman, who introduced really the Neyman-Pearson lemma and rigorous theory and testing, confidence intervals, at least an interpretation, his interpretation, which is the general one now, and mathematical rigor, which was not present under Fisher. This was really a difference, and Abraham Wald finally, who took Neyman's ideas more or less and developed them enormously with decision theory and sequential analysis. So both Neyman and Wald came from the continental tradition, which was indeed rigorous mathematics. The British had sort of a mixed sense. In fact, it's still reflected today at Cambridge. At Cambridge, there are two departments of mathematics. There's the department of of applied mathematics and mathematical physics, and the department of pure mathematics and mathematical statistics. And at Fisher's time, it was definitely the applied mathematics and mathematical physics which reigned. And basically, the idea is that Fisher was actually a superb mathematician, but rigor was certainly not part of his, he didn't care very much about rigor. He viewed that as minor. Well, an antagonism developed between Neyman and Fisher. In the end, initially they were friendly, and Neyman spent some time in London before coming to Berkeley. But eventually they became quite inimical, at least very much on Fisher's part. Fisher hated Neyman's interpretation of the framework which he had constructed. For example, worrying about type 2 error and the interpretation of confidence intervals. And he attacked him publicly. And actually on other matters as well, on issues of experimental design, actually. The primary attack was in that. So Neyman, although initially trying to not offend Fisher, he had great respect for Fisher, but later he reacted, and that went on with his students by minimizing key aspects of Fisher's work, such as maximum likelihood. I observed this as a graduate student in the main course. In the main course given by Eric Lehman, maximum likelihoods were hardly mentioned. And this sort of view of statistics also, was present in students, initially at least. So Eric Lehman's has this beautiful book, Testing of Statistical Hypotheses, but it focused on the Neyman-Pearson lemma and Wald's decision framework, and again, with relatively little reference to Fisher. Now, I didn't realize that there'd be any overlap between what Phil was saying and what I was saying. I'm sort of less polemic, let's say, about it. So Berkeley statistics, not operations research, by the way, was long seen as a center of frequentist statistics and as bitterly opposed to the Bayesian point of view, with one large exception, David Blackwell. David proclaimed himself a Bayesian all the time. Now, in fact, and this is probably more my view, Berkeley's position had nothing to do with the mathematical theory of probability, but everything to do with the interpretation of probability, subjectively or objectively. That was the center of the controversy at the time. And it manifested itself, really, I think, in practice, in applications, in the choice of measures of evidence. For example, p-values versus Bayes factors. My view is, at least at this point, the controversy is not very meaningful. And I think my view is that frequentists build models subjectively, as we all do. In fact, I would argue that our perception of reality is a collection of models. Bayesians, of course, try to persuade others of their conclusions. Right? Just believing in something probabilistically doesn't convince anybody other than oneself. There was an effect on the department, though, and that effect was to make Berkeley more favorable to simpler models and, as you heard from Phil, non-parametric statistics. It also made Berkeley, and this was not, that I think was good, but to some extent, but it also made Berkeley less likely to pay attention to methods like EM and MCMC. Here's a list of the faculty who joined the department between 1960 and 2000. Many of the names, unfortunately, as you'll see, there's a D behind for deceased. The others, I'll talk a bit in greater detail of the faculty as we go along. So as you'll see, there was quite a range of people. There were a lot of probabilists. However, some of them crossed over. In particular, David Friedman, and I would say Ani Adhikari as well, and Wari Millar. Wari is listed under statistics, but really was hired as a probabilist. And then there are joint appointments, which include people who were actually, in fact, like Sandrine, at some point became members of half members of the department or full members. Okay, but I'm not talking about anybody living, so that's. But I will talk about the deceased. Well, as I said, my talk is a bunch of history, opinions, and personal impressions. And I was particularly close to some of the founders. So one who I was very close to was David Blackwell. David did not get the honors he deserved because he was African American, but he had extensive impact in statistics, probability, and other areas of mathematics. He was really very broad. And you can see that in a list of objects bearing his name. There's the Rao-Blackwell theorem, the Blackwell renewal theorem in probability theory, the Blackwell channel in information theory, Blackwell sets in mathematical logic, and Blackwell approachability, which I didn't know about, but which has a bearing on a part of economics. He was really a wonderful person who had a very positive outlook, and quite a bit has been written about him, and rightly so. He did obtain the honors that he deserved, but only later than he should have. The second founder I was close to is also one that Phil mentioned, Lucien Lecombe. Lucien was a major contributor to probability and statistics, and what I found was he had a remarkable ability to shuttle between the very concrete and the most abstract mathematical structures. right? He would have a nice little drawing, and then he would suddenly go into L and M spaces. He also was a mild person, but who would occasionally fire off very intemperate letters to the administration. They seemed to have not much effect, but it made him feel better.
Can you say what topics he was?
Oh, I can't recall, but it was usually something fairly having to do with university rules, which he felt was silly. But I think I saw one of these long ago, but I've forgotten. But I do remember that he did it frequently. And with Neyman, I mean, since I said this is partly personal, he had the greatest influence on my directions of research. In some sense, I only appreciated this towards late. a lot of what I'd done was related to Le Cam's ideas. By the way, I think there may have been. He did not come to Berkeley as a faculty member or as a visiting scholar. He was a student. He got his degree at Berkeley. Neyman, with his acumen, spotted Le Cam, who had only a bachelor's degree at that point, in Paris, attending. The French have these seminars. So Le Cam would attend these seminars, and Neyman talked to him and persuaded him, which was very unusual for the French in that time, to leave France and come to the United States to get his PhD. The second founder I was close to, or third really, was my thesis advisor, Eric Lehman, major contributor to statistics. His books were the basic graduate theory texts for many years, Testing Statistical Hypothesis and the Theory of Point Estimation. They went through a number of changes and various co-authors who joined him and made them much broader. But from the beginning, he presented theory up to 1916 in a very structured form. He liked to talk about two classes of statisticians or mathematicians, problem solvers and systems builders. And he viewed himself as a systems builder, and Joe Hodges, with whom he worked frequently, as a problem solver. He was a dear friend as well. And as you saw, a historian of statistics. I have to tell you three anecdotes, which I can't resist. Hodges' class, undergraduate class actually in statistics, drew me into the subject when I came to Berkeley. And then, once I became a faculty member, he encouraged me to take an interest in university affairs. So I joined the graduate council after getting tenure and ended up collaborating on a study of data on possible sex bias in graduate admissions at Berkeley. On data which was gathered by Gene Hamill, who was then Associate Dean of the Graduate Division, and was intended as a guard against government oversight. And this has been, I think, the most read of my few ventures into applications. And I quote this also because to emphasize the importance of chance in my life, and I think the life of others as well. One seizes opportunities as they come. Lehman, as I think my wife mentioned already, when I complained about the unsatisfactory nature of my thesis, I really wanted to get through quickly. He assured me that the thesis is a union license. It's what's done after that matters, and I stayed in statistics. Le Cam, I remember, we were discussing Bahadur efficiency, which only some of you may have heard of. But it's a beautiful concept, which depends, however, on events, on rare events, probability of rare events, very unlikely events. And he asked me, Lucien, what do you care about events of probability 1 in a billion? And after that, I only worked with local approximations. Okay, again, another topic that I think I'd like to mention is that women have been welcomed in statistics at Berkeley. I can't speak for other departments, but it spread. Neyman included 3 women, as you know, among the founders. Elizabeth Scott, Evelyn Fix, and F.N. David was really not one of the founders, but she was a student in part of Neyman's in London, I believe. And then when she came to the United States, eventually got a job at Riverside, retired from Riverside, and then spent the rest of her life at Berkeley. And I remember her quite clearly. All were close to Neyman, all 3, and they worked on large applied projects in astronomy and cloud seeding, but also other things. For example, Evelyn Fix had a paper which was never published beyond a technical report, one of the first papers on density estimation with Joe Hodges. Scott, in particular, made important contributions to theory and, for better or worse, to our quarters in Evans. I put that in just perhaps to prompt some questions. But you know that she's well known. There's a famous paper of hers and Neyman's on if you want maximum likelihood estimate, but really models where you have number of parameters increasing with the number of observations, and of course a model in stochastic processes in connection with work in astronomy. Women have richly repaid their welcome, and I will mention some current faculty. Ani Adhikari, Bin Yu, Deb Nolan, Sandrine Dudois, Haiyan Huang, and Elizabeth Purdom have been central, I think, to the development of data science, the Computational Biology Center, and the College of Data Science and Statistics. What is it again? I never can remember the initials. What? Data Science and Society. Right, thank you. In various areas, basic structure, in curriculum, and development, and also in moving out of Evans. I'd also like to just mention biology and statistics at Berkeley. It was present from the beginning, biostatistics. I mean, beginning when Neyman moved, I think, I'm not sure whether it was when he founded his department or whether it was actually even earlier. But it was headed by Chin-Long Chiang and Nick Jewell after him, and then Sandrine. But this began with Neyman. It was all in the School of Public Health. Genomics came in with a major influence of Terry Speed, who attracted many students. He connected his students to faculty in molecular biology and industry, and some of his students became leaders in the field. Molecular biology expanded with the founding of the Center for Computational Biology, in which Jewell, Karp, and even I, to some extent, played a part. As ties to UCSF have also increased, I think biology has become a major part of work in applied statistics in our department. Now, I want to talk about second-generation faculty who were influential. They were not the only ones by any means, but they were ones who I think had the most effect on the basic themes in the department. So the first has been mentioned several times, David Friedman. He was actually hired as a probabilist, probability theorist, student of Feller's, and he did brilliant research in textbooks on continuous time Markov chains. But he then, as you've heard from Phil, became a major critic of statistical research in the social sciences, and also wrote the leading undergraduate textbook in elementary statistics, called Statistics, with Ani Adhikari at one time, and Bob Pisani and Roger Purvis. He also wrote a leading text, graduate text, in applied statistics, statistical models. And with David Brillinger, he was the constructor, David Brillinger was the constructor, actually, of applied graduate statistics course, Stat 215AB. And also he got involved in problem, I forget who was president at the time. It mattered, that was the key thing, of the problem of the census undercount. There was an East Coast group and a West Coast group. And the East Coast group tended to believe more in, if you want, one interpretation, and the West Coast group, led by Friedman, in the other. I think in the end, actually, the West Coast group was justified, but I'm not sure. I didn't take part, mainly because I thought it made no difference, because, in fact, what mattered was who would be in power at the time, the Republicans or the Democrats, as to which would be adopted. He also contributed quite a bit to theoretical statistics, and I was a collaborator of his. He in the rigorous treatment of the bootstrap and in various aspects of causal inference. The second influential to me, and I think influential to the department, was Leo Breiman, also trained as a probability theorist at Berkeley with Loew in 1954. He then left Berkeley, studied, became a faculty member at UCLA in mathematics and probability theory, wrote a leading textbook in probability theory, which he contrasted with the textbook of his thesis advisor, Michel Loew. He resigned from UCLA in 1971 to do statistics in industry. He rejoined academia with Berkeley in '81. He really brought machine learning and Michael Jordan to Berkeley in 1998. And as many of you may know, he wrote a famous paper called The Two Cultures, which I agree with in some ways and not in others. Okay. The third one, of course, was Jordan himself, Michael Jordan, who unfortunately is now retired. So I'm breaking my rule about talking about people who are here. But he's not here. Brilliant research. He anchored machine learning and ties to computer science, brought in new theoretical talents, Bartlett, Wainwright, and Recht, changed the emphasis from parametric models to the study of high-dimensional statistics, and with Terry Speed, changed the mode of PhD study to resemble laboratory science. I think it's just perhaps people now don't appreciate it because it's all done that way, but it didn't used to be done that way. The model was very much the model of mathematics, of individual or near individual supervision of students. And I would like to talk about a member of my faculty generation who's still with us but not present, David Brollinger, unfortunately not here. He was the major figure in applied statistics for many years. He was hired in 1970 with many important contributions, particularly to time series, but more generally. He wrote a major graduate text in time series, and with Friedman, he was the constructor of the applied graduate course, Stat 215AB. And he worked with colleagues on campus in applications to seismology, to biology, and many other fields. And he led many students to these disciplines, supervised outstanding theses. I would also like to mention a deceased older faculty member who was not, who was only a 0% appointment, Leo Goodman, who was the major contributor to statistical methods in sociology. He came to Berkeley in 1987 after many years at the University of Chicago. He was a dear friend. He's also the only one, I think, of all of the deceased who had an obit in the New York Times. Then I want to go through others who were mentioned. Jack Kiefer, who actually died very young, very distinguished probability theorist and statistician, an outstanding mycologist. And for those of you who want to know, mycology is the study of mushrooms, which, and he published in papers in mycology, journals in mycology. He died young in '81 at age 57, and he was also a very dear friend, both of Nancy's and of mine. Then deceased faculty members of my generation, Shel Doxham, my friend and collaborator for many years, joint author with me of Mathematical Statistics, volumes 1 and 2, and which I think, it's not and, which I think is a reasonably successful graduate text. And he made several important research contributions. And finally, Lester Dubins, a brilliant and unconventional probability theorist, whom I remember as author of a paper called How to Cut a Cake Fairly. And I can describe that if somebody asks me. It's very amusing. He collaborated actually with David Friedman, also with David Blackwell, but he did not convert to statistics. In fact, he never had a high opinion of statistics. Now, I'm going in alphabetical order. Rory Millar, also a distinguished probability theorist, hired as a probability theorist. For the first part of his career, turned to mathematical statistics, working with Rudy Barron. Made important contributions to min-max theory, among others, and he was a highly appreciated PhD supervisor. Roger Purvis, co-author with Friedman Pisani and Ani Adhikari of the great undergraduate text statistics, and longtime lecturer to very large undergraduate classes. Originally a probability theorist who became, I think, to some extent a mathematical logician with broad interests. He worked with Blackwell as Blackwell turned to mathematical logic. And he was also a good friend. And I think I'm going alphabetically. Chuck Stone, again a distinguished probability theorist, who came to Berkeley to work, however, already a convert. He came to Berkeley to work with Leo Breiman. He wrote the CART book, which was fundamental classification with Leo, Jerry Friedman, and Richard Olshan. He moved to theoretical statistics, was one of the founders of min-max theory for high-dimensional objects, and supervised a number of outstanding theses. And now I can just list very much alive members of the older faculty generation. David Aldous, Steve Evans, who's here, Mike Klass, and Jim Pittman, all probability theorists. For some reason, the probability theorists seem to be longer lived than the statisticians. Or maybe there's just fewer of them. And in statistics, Ani, Rudy Barron, David Berlinger, who's been gone from Berkeley for a long time, Xing-Shui Cheng, Michael Jordan, Deb Nolan. These are all people who were appointed before 2000. John Rice, Julie Schaefer, Phil Stark, and Binu. And many others with appointments in other departments. And I guess I want to say something for the staff, because a wonderful, and as with faculty, usually congenial group, all I think joined after 2000, at least of those present, and highly responsible for the warm atmosphere of the department now and in the past. All right, so finally my slight pontification, my hopes for the future. One, of course, for the College of Computing, Data Science, and Society. I hope that statistical methods, it will foster statistical methods between all areas in which data is crucial or becoming so, and that including the biological, physical, mathematical, and social sciences, humanities, and even the arts, I think. Really all fields. Now I will just say that this is now really just me. The challenge I find most interesting is understanding the parallels and differences between artificial and human intelligence, and applying this understanding for the betterment of mankind. And in this enterprise, I think there are roles for everybody. Probability and statistics, computer science, neuroscience, psychology, engineering, and so on. And I really do hope that being in the College of Computing, Data Science, and Society will contribute to this, because proximity is critical to large endeavors. And I think that's the end. And nobody's asking. Yes, of course.
Thank you, Peter, for the wonderful talk. We have plenty of time for questions, so people would like to. Peter seeded a few questions that he was hoping people would ask. If anybody would like to ask any of those questions, now's the time.
Yes. Sorry, I can't hear. I'm sorry. You know, I can't even see your face because of the glare. Okay. All right. Yes. Okay.
Okay, so anyway, way back when I was teaching, oh, thank you. Way back when, does this work? Okay, can you hear me? Yes. All right, I haven't used one of these things for decades. So way back when I was teaching 210, doing the hypothesis testing segment from Eric's book, I mentioned to the class.
Now I know.
Yeah, now we're getting serious. Okay, so I mentioned to the class that, of course, these models and so forth are hypothetical.
Yes.
And I thought that was an innocent comment. I was very young. But apparently the word got back to Neyman, and I was informed somewhat later in the week that he was somewhat upset by this comment. And so I actually read some of his early publications. And in his mind, probability theory operated in the real world. It's something he saw ahead of him. And that's why frequentist theory made sense to him. And this is very different from Kolmogorov's point of view. I mean, Kolmogorov wrote in print in the 70s, and I think he believed it earlier, that a problem arises of establishing the applicability of probability theory to the phenomena of the real world. So, in other words, Kolmogorov didn't buy the statistical stuff that Neyman was pushing. And in between all of this, of course, was the book by Richard von Mises. Was it Probability, Statistics, and Truth, or some other order of that? And Neyman was one of the translators of the original edition. I once noticed that in the preface.
Sorry.
It was in German. This was von Mises' book, his foundations for probability, as distinct from Kolmogorov's. And Neyman was on each panel that translated that into English. So, there are all sorts of personality things going on in here. But anyway, Berkeley inherited Neyman's view, and I think that's the main point. And I think you've made that very clear. So thank you.
Well, thank you, Rudy. I mean, I'm, as many of you may know, I'm not really a scholar. Unfortunately, I inherited the tendency of trying to do things from first principles for some reason. But anyway, yes, that's very interesting. I didn't realize that. Probability, I mean, that's really the question that I asked Phil, which is what is probability? And I think the probability theory is, well, it's interesting that Kolmogorov, I'm not sure quite how he saw it, but anyway, with Kolmogorov, I associate purely the mathematics. And there's no question about the mathematics. We all agree that this is a reasonable mathematical construct, and it works, and we know how to operate with it. But how you interpret it is the issue. And I frankly don't think there is a simple answer. And I think that's been, the literature sort of bears that out, right? As you mentioned von Mises, who had one view, then of course Jimmy Savage, who believed that we would be, we're irrational if we aren't Bayesians, and have personal probabilities for everything. So anyway, that's, thank you. Yes. Ben. Oh, sorry.
Well, it's not really a question, just continue some stories. Peter started about Lacan, who was one of my advisors with Terry Speed. So about breaking rules, one thing Lucian told me, which I still remember, is like rules supposed to help, not to hinder. As a graduate student, I used to remember he would write letters. I think one was about parking or something. I don't remember.
That's right. That was what.
And the other thing about how incredible Neyman was able to recruit Lucian from France. Lucian told me that not just that he brought Lucian to San Francisco, he actually sent the daughter, a friend of his, to meet Lucian, who later became Lucian's wife. And Lucian never left.
That I did not know at all.
So, multi-steps.
Yeah.
I have to ask, what did Elizabeth Scott have to do with Evans Hall?
Ah, okay, good. Thank you. Thank you, Ryan. Well, so first of all, Evans Hall, from the very beginning, I think, was against the campus plan. What was intended there were two small buildings, which were not very tall. But I'm not sure that Elizabeth was instrumental in this, but finally they did decide to make one larger building. However, they did not intend it to be 10 stories originally. But Elizabeth got a large grant from the National Institutes of Health at the time for building purposes. And she persuaded, I guess, the NIH and also the university that really statistics was an applied science, needed labs, and therefore the offices had to be enormous. They had to be the size of the offices of people who, experimental physicists, people like that. And then we got Evans Hall. Unfortunately, it's not, it has lots of space. It bears, I think, it's not the most beautiful building on campus. In fact, I would say it's the second ugliest building on campus, the ugliest being the architecture building, which was designed by the same guy.
Peter, you mentioned actually in Elizabeth a connection to the astronomy department.
Yes.
One of the things that I've been impressed here at Berkeley is that there are good collaborations with astronomy agents today. Josh Bloom is somebody who has been very good.
Yes,
In fact, he
right.
has his lab in our building. Do those connections today, and is that a continuation of that thread?
No,
Or is it accidental?
I don't think so. I mean, certainly Josh Bloom, I think that was more due to contact with John Rice, I believe. So much later. But actually, if you look at the Berkeley Symposia, you will see articles, papers by practicing astronomers, but not the central pieces.
I think there was a couple of decades when I was the only faculty member working in astronomy.
That's right. Okay. Well, I always think of you as a geophysicist, not as an astronomer.
Yeah. That's the only thing I have formal training in. I was working in cosmology and heliocosmology.
Anyway, I'm sorry.
I worked with the astronomers too.
Oh, you did?
Yeah.
Wonderful. This is Ken Wachter, by the way. And so when did you work with astronomers?
Joe Sell.
No, when though?
When in the 1990s.
But this was not a follow-up to, not a follow-up to Neyman's ties, right?
Well,
Or was it?
I was strongly influenced in doing this by Betty Scott, yes.
Oh, were you? Oh, so I was wrong. I'm glad to hear that.
Presence in the minds of the astronomers.
Aha. Okay. That was not certainly not evident to me when in the department. I mean, of course, Neyman was teaching a course on applications to astronomy and weather modification, but the subject of that course seemed to be largely little bits of theory.
C alpha tests were used for that.
I'm sorry?
C alpha tests.
The alpha test. Oh, the C alpha test, yes.
Okay, I'd like to, one more question back there.
I go back to Campbell Hall for Evans Hall. And I remember best is the coffee room.
I'm sorry?
What I remember best from Campbell Hall
Yes.
before Evans Hall
Right.
is Betty Scott always having a cake for the graduate students to encourage their communication.
Yes. No. Betty was a major. Thank you. Betty was a major force in sort of keeping the department together. She also had a rather more intimidating side. My first experience of Betty was I had just joined the department as a student, and there was a coffee room in Campbell Hall, as you're told, and I had gone there, and I'd forgotten my jacket. I do these things all the time. So when I went home, I then had a telephone call, and it was Betty. And she asked me, "Is this your jacket? Is this your jacket in the coffee room?" I said, "Oh yes, I forgot it. I'm sorry." She said, "Come and get it." I said, "No, it's okay. I have a key." "You have a key?" I wasn't a teaching assistant at the time. I had a fellowship, so only teaching assistants were supposed to have keys. So that was, so I had to go over immediately and pick up my jacket. Yes,
You might as well tell about the coffee cups and the books as well.
the coffee cups in the, I don't even remember that. You should tell about the coffee cups.
Benny used to collect your dirty coffee cups and return them to the coffee room
Yes,
with a note.
I actually had forgotten that, so.
She also returned your library books during the vacations.
Go.
She was also very much a champion of the master's program, master's students, defender of the master's students.
Yeah, yeah. No, she was great, and she and Neyman together really hosted a lot of things at, I guess it was really Neyman's house more, but or maybe no, her house. Was it?
She would cook at Neyman's house.
Ah, okay, okay. So yeah, no, she played a big role, and anyway, thanks, Nancy.
Okay, I would like us to give Peter a huge round of applause.